Hello students, today we'll be solving exponential equations, but before we do that, I would like for you to try coming up with answers for 1, 2, 3. Please pause the video and then come back once you're done. Welcome back. If you recall, we have learned that when we have a power raised to another power, all you have to do is multiply the exponents and keep the same base. So we keep 5 and we will multiply 2 times 3x. That's going to be 6x. That's all we can do right now, and so you leave it as that. For the next one, we do the same thing. We just multiply 4 times 5. Keep the base. 4 times 5 is 20. And if you're asked to raise 3 to the 20th power, then you can go ahead and do that. But for this lesson, we're just going to leave it as 3 to the 20th power. If you were to find the answer, all you have to do is use your calculator, press 3. In some calculators, you have this arrow for the power, and then to the 20th power, it'll give you, and the number is 3,486,784,401. It's easier when you can see the commas. Okay, number 3 says, is 5 cubed equals 125? Well, the way that we can do it is to change this into a power. And so I just put 125, start factoring. Since the base in here is 5, I'm just going to put 5. And that's the only factor that it can be divided into anyways, or 25. So 125 divided by 5 is 25. If you need to use your calculator, go ahead and use it. Then in here, 25 is 5 times 5. As you can see, the prime factors, and this is prime factorization, the prime factors in this prime factorization is 5 times 5 times 5, which is 125. We put it in here. It's just 5 multiplied times itself 3 times. Bring down the other side, and you can see that 5 cubed equals 5 cubed, so we say yes. Okay, check. Now this is going to help us for the rest of the lesson when we're going to be solving exponential functions. Okay, number 4 here says 3 to the x plus 1, that's my exponent, my power, equals 3 to the 5th power. Now when we have the same base, all we have to do is create an equation with our powers. You have to have the same base. So in this case, since we already have that, we just put x plus 1 equals 5. We subtract 1 from both sides, and x is equals to 4. So that's the answer. That's what you're going to be doing when you're solving for exponential functions. You're just trying to find what the value of x is. Now, what if you want to check to make sure that that's true? All you have to do is substitute this 4 into the x up here. And so we put 3x plus 1 instead of x. We already know that the value of x is 4. 4 plus 1. Is it equal to 3 to the 5th power? We add this, and so we get 3 to the 5th because 4 plus 1 equals 5 equals 3 to the 5th power, so we say check. Okay, for number 5, again, we already have the same base. So all we have to do is create an equation with the 2 exponents. So we have 3x equals 2x plus 3. In here, we have exponents on both sides, so we have to cancel the 1. If you're not sure, I recommend that you cancel the 1 on the right, but remember that some people notice that sometimes that's not the best option. But in here, we're going to subtract 2x because we cannot have x on both sides of the equal sign. This cancels. 3x minus 2x is x. Bring down the equal. Bring down the 3, and you don't have anything else to do, so the value of x is 3. Now we're going to substitute just to check but this is what we are looking for, okay? Now we're going to substitute this into x to make sure that they check. So 10 to the 3x, but instead of x, we know that the value is 3, and that's multiplication, okay? Is it equal to 10 to the 2 times x, but the value of x is 3, plus 3. Okay, we don't know. Let's check. Bring down the 10. 3 times 3 is 9. Bring down the 10. 2 times 3, that's going to be 6. 6 plus 3, 6 plus 3 is 9. So we say, yes, it is the same, so check. Okay, so what about when we don't have the same base? Well, we have to do factorization. However, we're going to use the tree, but we're not going to use prime factors in here. We're going to use this base, which is 4, and we're going to start dividing. 64 divided by 4 is 16. If you're not sure, you can divide it with your calculator. Again, 64 divided by this one, and put the 4 in here and put the answer in here. Then 16 is the same as 4 times 4. If you notice, we have 4, 4, and 4 as the factors for 64. We are now going to use it in here. Instead of this 64, we're going to write those factors, but with the power, because it's 4 times 4 times 4 is the same as 4 to the third power. Now we can make an equation with the exponents, which is what we did with the previous two examples. So we put x equals 3. Since we don't have anything else with x, that's all it is, and so x is equals to 3. Now in here, it would be hard to go back and substitute in here, but we can substitute the replacement, and if you didn't make any mistakes in here, then it will check. However, if there were some mistakes in here, it might say, oh, this is a true answer. The solution is checked correctly, but that's only if this matches this, okay? I don't know if that makes sense. So now, this is the one that we're going to check, and so we replace x with 3, so it's 4 to the third power is equals to 4 to the third power, so we say yes. Again, if the substitution in here was not done properly or wasn't correctly, if it wasn't done correctly, then this might check correctly for this one, but not necessarily to this one. So we have to be very careful in here. Okay, for the next one, we're going to do the same thing. Why? Because we don't have the same base. Again, we're going to do factorization with this one. The base is at 2, so this time it is going to be prime factorization. 256 divided by 2 is 128. Again, if you can get that easily, then just go ahead and use your calculator for now. Hopefully with practice, you'll get better with the multiplications. In here, again, divisible by 2. 2 times what number equals 128? It's 64. 2 times what equals 64? 2 times 32. 2 times 16 will give me 32. 2 times 8 will give me 16. 2 times 4 is 8. And 2 times 2. Whew, that was a long one. So we rewrite this one. Let me just separate it. So we rewrite this as 2 to the 2x plus 4 equals, instead of 256, I'm going to count how many 2s. So 1, 2, 3, 4, 5, 6, 7, 8. So that's 2 as the base, and then to the 8th power. Now I have the same base. Now I can create an equation in here. So it's 2x plus 4 equals 8. If I'm adding, the opposite of addition is subtraction. And that's to cancel the plus 4. Now I only have 2x equals 8 minus 4, 4. Finally, if it's multiplication, the opposite of multiplication is division. And if I divide one side, I divide the other. Remember, in multiplication and division, we keep the same sign because positive divided by positive will give me a positive. But if you change the sign, positive divided by negative would be negative, and we don't want that. We would get a negative x. No, no, no. Keep the same sign, okay? In division and multiplication, we bring the same sign. So now you have x. 4 divided by 2 is 2. And now let me just do the check somewhere in here. So again, we're going to check this part, hoping that we did this part correctly, okay? So now that we know that x is 2, let's substitute the x right there. So it's 2 to the 2 times x, but x is 2 right here, plus 4. Is it equal to 2 to the 8th power? And it's a question mark, okay? Now bring down the 2. 2 times 2, 4. 4 plus 4, 8. We bring down 2 to the 8th power, and we see that it's the same, so we say check. Okay, so in here, again, we don't have the same base. We're going to convert the 16 to 4, and we know that is 4 times 4. That means that this new base is going to be 4 to the 2nd power. So bring this down. 4 to the power of x plus 2 equals. Now, this 16 is going to be replaced by this power, 4 to the 2nd power. However, we already had a power in there, so that's what you're going to bring it into a parenthesis so that you can put the x in here. And if you remember from number 1 and 2, when we have a parenthesis with a power inside and a power outside, what we do is multiply the two exponents. It's a power raised to another power. Bring down 4 to the power of x plus 2. We keep the base 4 and multiply 2 times x is 2x. Okay, now we're just going to do the same as we were doing. When we have the same base, now we can just create the equation. So it's going to be x plus 2 equals 2x. Here is where I tell you, usually it's better to subtract the one on the right if you're not sure, but in this case, we don't have a constant in here. So it's better to just subtract the x from this side, and if we do it on one side, we do it on the other. This cancels, and you just get 2 equals 2x minus x, x. Now for the checkup, you can either check this one or this one. Either one is fine. I'll go ahead and check with that one. So we're replacing both of the x's by 2, which is what we found. Okay, so right here and right here. So it's going to be 4 to the, instead of x, is 2 plus 2. Is it equal to 4 to the 2nd power, all raised to the x is 2. So we replace that x with 2 as well. And for the next step in here, we add 4 to the 2 plus 2 is 4. In here, because one is inside and one is outside and both are exponents next to each other, it's a power raised to a power. So we keep the base and multiply the exponents. 2 times 2 is 4. And we see that it's the same, so we say check. Okay, let's go to the last one, number 9. Again, we don't have the same base, so what are we going to do? We're going to make this into the same base. 125 is 5 times 25. 25 is 5 times 5. So we rewrite this as 5. Let me write it in here. 5 times 5 times 5 is the same as 5 cubed. Okay, so this replaces the 125 in here. So bring this down. Equals, instead of 125, we're going to write this. Because there was an exponent already, that's why we put it in parentheses and bring down the exponent that was there before, now outside of that parentheses. Again, we learned that when we have a power raised to another power, we multiply the exponents. And so rewrite this as 5 to the power of 3x plus 9 equals 5 to the 3 times 2x is 6x. Now that we have the same base, we can create an equation with the exponents. And so we get 3x plus 9 equals 6x. In here again, we don't have a constant in here, so it's easier to just cancel this whole term. If I'm adding 3x, the opposite is to subtract 3x. So when do you subtract the entire 3x or the entire term? Is when we have x on both sides of the equal sign. Okay, remember that. And so this cancels. We get 9 equals 6x minus 3x is 3x. Finally, if I'm multiplying, the opposite is to divide. And x equals 9 divided by 3, 3. Now I'm going to check with this one right here. Again, it'll check right to this one, but hopefully you did the right step going from here to here, okay? Okay, so it's going to be 5 to the power of 3 times x, which is 3 plus 9. Is it equal to 5 to the third power, and then, or 5 cubed to the 2 times x, but we know that x is 3. Now in here is 5. 3 times 3 is 9, and 9 plus 9 is 18. In here, we have 2 times 3 is 6. Okay, let's just, this 2 is 6, and then because the 6 is outside and this one is inside, maybe I should do it in an extra step just so you don't get confused. So 2 times 3 is 6. Bring down this one, 5 to the 18th power. And then again, you multiply these ones. If you are able to do it directly in here, that's fine. 5 to the 3 times 6, 18. 18th power. They are the same, so we say check. If you can please subscribe around here. This is the link to the next lesson, and here you will find the entire unit. Now you're able to solve exponential equations and have fun.